Okay. Oh, what is this business? Not what we want. Let's go back over here. Okay. So we had gotten up to just opening a chart. But let's clear this. Let's start this fresh because you're going to do this tonight for homework. We have a bunch of data, and I want you to plot the data. We're going to make a graph that covers the distance versus time data, the average distance versus time data for steady cart, for husky cart, and for tank cart. So, how do we go about that? Well, actually, pretty simple process, and it's iterative, meaning you're going to redo it this way all year whenever we have to graph. So it's a nice thing to get used to. First things first, let's insert a chart. You can either click Insert Chart. By the way, sometimes people highlight things before they insert a chart. Don't waste your time. You can go Insert Chart, or you can find over here the little chart icon, Insert Chart. They both do the same thing. All right, now mine popped up this. All right, I don't particularly care what Google Sheets decided for me. I'm going to change it. I'm going to edit it myself. The best thing to do is restart, refresh, start this thing totally from scratch, because then every time you'll know what you're doing. So right now, if we're in the setup heading here, in the setup, notice it says x-axis time. That's actually correct, but I'm going to show you how to do this from scratch. So I'm going to click those three vertical dots, remove. Series, which means y-axis. Series, it says average D. That's actually what we want too, but I'm going to remove that one too. So now we have no data. We're truly starting with a fresh or a blank slate. A tabula rasa. Okay, let's go. So first off, let's pick some data. We want to add an x-axis. We are doing a distance versus time graph. So for our x-axis, we are going to put time. Now, there's one advanced step here, and the advanced step is as follows. Uh, because, let me move this graph over, we are doing data for steady cart, husky cart, and tank cart, we need to have time that will accommodate all three. Steady cart's time only goes up to 1 second for our group, our class. Husky cart goes up to 1.4, and tank cart goes up to 1.1. So we want to be able to accommodate all of them, which means we need to have up to 1.4 seconds. Now, the other class, you'll be watching this too. Uh, you may have different numbers, but it's the same game. Anyway, we click Add X-Axis. So let's go in here and click. Now, follow me on this. If you don't follow this order, it will not work. Once you click Add X-Axis, I just unclicked it. Let me re-click it. There is a 4 square over here. It says if you hover over it, select the data range. Click on the 4 square. Now, I am going to select the data range for this. I will come over here. This thing can be moved around if it's in your way. Remember, 1.4 was our greatest time. This is for period 1, 2. Period 7, 8 may be different. So what I will do is I will click on the word time, and I'm holding down the mouse, left click, and I'm dragging all the way down to 1.4. Boom. There it is. Now, if your mouse doesn't work on your laptop, let me clear this off. There's another way to do this. I mean, your mouse will at least work to make one click, but if it's problematic, click on that first time box. It's in cell B22. Press the shift button on your keyboard, and then press the down arrow while holding down shift until you get your full 1.4 seconds. Then you let go, same result. We press OK. Boom. An x-axis has been added. Let's see if our graph is showing anywhere. Where is our graph? I don't even know where we put it. We'll find out. Here it is. No data yet because there's no series. An x-axis alone will not get you data. Okay, we are going to add a series. The series is just the y values. The series is actually what should be the dependent variable. So let's add a series. Click on it. Again, click the 4 square. Boom. Select the data range. The first one we're going to do is for steady cart. So I'm going to move this out of the way. I'm making sure that I am not on one of the others, but I'm on steady cart. I will click average distance. That's why we calculated the averages, and highlight all the way down to the bottom. Press OK. Ooh, we've got a graph. Oh, isn't that nice? Yes, it is. All right. Now, there are some other adjustments we're going to make, but we're not there yet, so hold. So we had one series. We're going to add another series. Our next series is actually our series for Husky Cart. So let's click Add Series, Foursquare, to select the data range. This time we're going to go to Husky Cart's chart, start with the average, and highlight all of the cells that have magnitudes for us, and click OK. All right, now we have two series involved. Let's go up here. Look at that. Not bad. We're going to change the look of the graph in a little bit. Now let's add one more series. So we had Steady Cart, Husky Cart. Now we need Tank Cart. Add a series. Click our little Foursquare, which is select the data range. Move this out of the way. Tank Cart's average distance over its time period. Click OK. Boom! We are almost there. Cooking with gas, as they say. So, all right, we have three different carts, three different graphs on the same grid. That's what we wanted. Now, we have some adjustments to make to the chart. By the way, if you ever X out of the chart editor, oh no, what do I do? You can always just double click and boom, there it is again. Now I'm going to grab my graph and move it over a little bit. The reason I'm going to move it over a little bit is so that I can see the chart editor commands and also see the graph at the same time. Okay, so we are going to go back to setup. If you're not in setup, go to setup. This is a line chart right now. We don't want a line chart. A line chart is actually very good if you want to follow the individual movements of the data points. So if you want to find detail by detail, moment by moment data point, a line chart will follow that pretty well for you. There's a question down here that says, let's see, how do we select the graph type? Well, here's the answer to that question. We select the graph type based on what sort of information we want to get from the graph. So what do we want to get? I mean, there are definitely other options. A line chart is an option. If you want interval to interval details, you select a line chart. But we are actually going to select a scatter. Scroll down, scroll down, scroll down, a scatter chart. We're selecting a scatter chart for a particular reason that we'll get back to in just a moment. There is our scatter chart. That's what I want this to look like. Now, let's edit this a bit. Let's go to customize. Okay, let's do a few things here. First, let's deal with these dots. We have this comment series. Series is the data. Those are the Y values. So let's click on the series and let's make some adjustments. First off, the dots are too big. Let's make this, the circles are too blobby and it's too big. Let's turn these into like X's. That's nicer. And we can even make these a little smaller. 7 pixel. You could try 2. You know, maybe you want to go up a little bit. Maybe we can go up to 4. Yeah, something like that. Good. We don't want the blobs overwhelming where what we're about to do is add trend lines. Now, that question down here, so we are answering these right here, so pay attention. Why are we doing a scatter chart? Because we don't want the individual interval to interval details of this. What we want is actually the trend line. Here it is. What we want is actually the best fit line. That gives us the trend or the tendency of the cart's motion over the entirety of the interval. That's what we're interested in for this lab. So for this lab, notice this says apply to all series. It's good. It'll do all 3 lines at once. If you wanted to individually deal with just the blue or just the red or just the yellow, you could do that. But all series will do it all at once, which is nicer. Add trend lines. Boom. That is a best fit line. Notice it does not automatically hit every single dot. Some dots are a little off. Some dots, even here, though it's kind of hitting them, notice that some are a little high on the line, some are a little low on the line. That's a nice best fit line. Now you're going to do something else cool here. There's no error bars for us to add. Something else cool is going to be this, a label. The label is going to do for us what I sometimes have you do for us, which is find the equation of the line, which is finding the slope. So if we come over here, label, use equation, boom, there it is. So we have the equation for each of these. Now we're going to be able to move this around so it's not so messy and clunky. But it's nice to have the equation. The equation tells us a lot about what's going on in that line. A pretty cool thing. All right, good. Don't show the r squared. Okay, now we got to neaten this thing up. Notice there's nothing listed here, so we can scroll up and close up series. Notice, what is this x-axis? We don't even know. So let's go here, chart and axis titles. Here we go, chart title. Good. The chart title is average. We don't need it all capped, by the way. Average distance versus time. Now, actually, a chart title should include more details than just the headings of the axes. A chart title can have a subtitle, and our subtitle will be steady cart, husky cart, tank cart, hallway race. Cool. So now we actually know what this is about. So if we look over here, yes, this is average distance versus time. However, we know the context. These are 3 different carts having a hallway race. And that'll remind you of what we actually did. You can now this part's up to you, by the way. You want to mess with the colors, you want to mess with the font, go ahead, have fun. I don't care. That's up to you. All right, now notice we need to still title the horizontal and the vertical axis. So we're staying in this category, chart and axis titles. However, we're going to do the chart subtitle. Horizontal axis title. Horizontal axis title is time in seconds. Then we can go over to vertical axis title. Vertical axis title, I don't want all caps there. We'll have average distance. We'll write it out as distance in centimeters. Cool. And you'll see it adjusts over here. All right, this is starting to look pretty good. I mean, we're not completely done yet, but this is starting to look pretty good. Give me 1 second. Let me make sure the volume is actually working.
We're going to do a simple thing.
Yes, we are. That would have been upsetting if I were recording all this and the mic weren't working. All right, that would have been a mic drop. Anyway, back over here. So let's make this thing look nice. Let's go back to setup for a moment. And one of the things I noticed was here, use row 1 as headers. Okay. Use column B as labels. I don't know that I want to do that. Let's check that. Nope, we do want to do it. Don't mess with it. We can mess with some of that junk later. Anyway, let's go over here and I believe we can name these series. I wonder. Sometimes I forget how to do these things. I haven't seen them in a while. Don't worry about that. If any of you remember how to name the series, you can tell me later. Or I can figure it out later. Anyway, back to it. Let's go. This looks almost nice. One of the things we have a problem with here, though, is axis should go down to 0. So let's go to horizontal axis. Let's see if that does it for us. Okay. Here we go. Minimum value. So horizontal axis, minimum. Let's put a 0 in there. Uh-oh, I hit reverse. Sorry, unhit reverse. Good. Put a 0 in there. Excellent. Now that actually gets us all the way down to, you see, they all almost hit the origin, which is pretty good because they should have been at 0 centimeters rather, at a time of 0 seconds. All right, cool. Now, let's check this here. Our max time was 1.4, if you recall. And this, I'm not sure if it quite makes it, but it looks like it's going by 0.25s, which I kind of like, actually. Let's run this over to 1.5. Good. Clean. No problem. All right. Now, let us, this is the horizontal axis, let us straighten out the vertical axis. Now, the vertical axis, it looks like maybe this line here gets cut off. Maybe there's a data point that's cut off. I'm not sure. That's up to 60 centimeters. Let's move this over and let's check. Steady cart, the most we got was 56. Husky was 13. Tank was 26. So no, we're good. Nothing goes higher than 60 centimeters. All right, this looks pretty good. Now it's just a matter of how you want it to actually visually appear. So you can X this out over here. And one of the things you can do is move the legend around. There you go. So I double clicked. Let me show you what I did there. I closed this. I double clicked over here. And you can move this legend around. Pick it up over here. You can stretch it out. I'm not that big a fan of the legend. I wonder, let's see here. Position. What if we have none? That's not so bad. I didn't really like the look of that legend. This is a little nicer here. Okay. Now the only thing I'm missing, which I would like though, are those trend lines. So let's see the trend line equation. Let's see if we can put those equations back on. Series, trend line, label. Will it show it to us on here? Well, I know there are ways to do it, so let's put the legend back for the time being, just so you can see the equation. Let's put it on the bottom. There. Now, I haven't looked at this in a long time. There's definitely a nicer way to name these series other than 5.48, 0.89, and 2.38, and we'll worry about that in class. But you should come in here basically with something that looks like this, with these equations labeled. Now, if we come down to the questions, how do we select the graph type? We already talked about. How do we set the axes? The axes are typically set with the dependent variable on the y-axis and the independent variable on the x-axis. The independent variable is the one that you control, and the dependent is what comes out. So the one we controlled here was the time via the spark time. So if you set it to 10 hertz, which is what we did, you know you're getting a dot every 1/10 of a second. So that's the way we set the axes. The other way we set the axes, though, is we want the slope to be interesting. In this case, we had distance and then time. D over T gives us a physical quantity we want. T over D does not. So for two reasons, both the dependent versus independent and also a useful slope, that's why we set the axes as we did. The other questions we will look at together, and we'll discuss those in class. And then we'll do a little final bit of editing. But you need to come in with this tomorrow, plot it out nice like this, because we'll do a little editing in class. We'll answer the last questions, and you will submit in class. All right.